Example 21. Determine the resultant of the three forces acting on the dam shown in the figure and locate its intersection with the base AB. So of course, given our angle is given, which is 60 degrees for the inclined portion. Okay, so we do resultant force first. F sub r. F x component of our F sub r is equal to the sum of all the forces in the x direction, assuming to the right positive. So we have, this is equal to, let me zoom in a little. Okay, and pan. Okay, so this is 10,000 to the right, 10,000. That is in pound, of course. And then 6,000, the x component. Okay, we write going down. Right, going down. So of course, if this is 60, this is 60 as well. Oh, is that 60? This is 30. Because this also here is 60 degrees and that is perpendicular. So we use 30 degrees. So that is 6,000 minus 6,000 cosine 30 degrees, and the x component of our resultant force is equal to 6,000 cosine 30. That's 5,196.152423. That's 10,000 minus answer. So that is 4,803.847 847577 pounds. Okay, so for our F sub Ry is equal to the sum of all the forces in the y direction, assuming upward positive. So this is, we have going down all. So that's negative 24,000, which is the weight of our dam, minus 6,000 sine 30. Sine 30 degrees. Okay, so this is equal to 6,000 sine 30 plus 24,000. So this is negative 27,000 pounds. And we write it following its true sense. So that's F sub R y is equal to 27,000 going down. So our magnitude of F sub R is F sub R is equal to the square root of F sub R of x plus, oh, not of, but sub x sub R sub y squared. We substitute the values for our F sub Rx, that is 4, 8, let me zoom out, okay, 4803, 4803.847577 squared plus, okay, plus 27,000. squared. So our F sub R is equal to 4803.847577 squared plus 27,000 squared. Square root answer, that is 27,424.02143 pounds. For our direction of F sub R, we have theta is equal to inverse tangent F sub R y over F sub R x. So we have inverse tangent of F sub ry is 27,000 divided by 4,803.84757, parentheses of course. So our theta is equal to 27,000 divided by 4,803.84757 tangent. So that's 79.1148754 degrees. That is, of course, going down to the right. Going down to the right. So this is our. So now if we can observe, we are tasked to find the intersection with the base AB. So we have, therefore what we will do is that we will find the moment summation about point B. So by the problem itself, we can say that our resultant force is subjected going down here. Okay, and we will need to calculate this distance. So let us call that as x measured from point B. Okay, moment summation m sub r about point B. So that's m at about point B. So that's m sub r point B is equal to the sum of all moment at point B, assuming counterclockwise positive. Now, if you can observe that if our uh, the line of action of our force F sub R is indeed subjected here, represented by color blue, it does create a counterclockwise moment about point B. So one way to know is that we will uh, measure first the uh, resultant moment using our 10,000 force, 24, and our 6,000 pound forces. So that is, this is equal to, we know that F sub R times its perpendicular distance. Okay, and that is, we counterclockwise. So we know that our 600-pound force is applied perpendicular to our incline, and the measure would be 4 feet, so that we immediately write 6,000 times 4. Next, we have 24,000 going down, plus 24 thousand. Now, if we can observe that the distance from A to our 24,000 is 7 feet, and the distance from A to B is 18 feet. So therefore, we subtract 7 from 18, and we get the perpendicular distance would be 11 feet. 11. And then, of course, our last remaining force, which is 10,000, which is applied to the right with a perpendicular distance of 6 feet. So that's minus. It creates a clockwise moment. So that's minus 10,000 times 6. So this is 6,000 times 4. We have 24,000 plus 24,000 times 11, 11, that's 264 minus 10,000 times 6, so that's 60,000. So F sub RD is equal to 24,000 plus 264,000. That's 288,000 minus 60,000. That's equal to 228,000 pound-feet. Now, we are not simply asked to find for the perpendicular distance of our F sub R, but rather the point where our F sub R passes through AB. So therefore, what we can do is we use the Vergnon's theorem. We write the y component F sub ry and our x component at line AB. F sub rx. Of course, a perpendicular distance of our F sub rx is 0, and the perpendicular distance of our F sub ry is x, which is, again, the distance where our F sub r passes through AB, which is measured from B. Okay, so we write it. Our F sub ry is 24,000. It creates going down a clockwise moment. So that is but before that, let me rewrite this one as F sub ry, that is 27,000 times x plus our F sub rx. I will not have to write, I will not write the entire value of F sub rx, because it's quite long, but we know that F sub rx times 0 is equal to 228,000 pound-feet. So this becomes 27,000 x is equal to 228,000 pound-feet. Divide both sides by 27,000. 27,000 x is equal to, divided by 27, is 8.4 repeating feet. This is our value measured from B. Okay, now again, if it was not specified in our problem, let's say here it is specified that locate its intersection with the base AB, man, good. But if, let us say, just the distance from our F sub R to B, then we simply substitute in 2742.02143 times D is equal to 228,000, and we find D. But again, specify man yun diri nga ang point kung asa ni intersect sa isa ka certain line, which is or base AB. Okay.